Let's take a look at another example. Example 2 is 3x squared equals 4x. 3x squared equals 4x. Notice that this is not in standard form. We can spot it instantly by noticing that the right-hand member of the equation is not 0. We must have the right number equal to 0, so let's get this in standard form by subtracting the 4x from both sides of the equation. 3x squared subtract 4x equals 4x subtract 4x. On the left side, we cannot combine terms because they're different powers of x, not like terms. So we get 3x squared minus 4x equals 0. And there's that all-important 0 on the right-hand side. Without the 0 on the right-hand side, we cannot proceed. On the left side, we're ready to factor. How do we factor this one? Notice it only has two terms. Remember that the first kind of factoring we learned, and in fact the easiest kind of factoring, is the common factor. What common factor can you see in these two terms? The only common factor they have is x, or 1x. We'll factor x out, and that leaves x times 3x subtract 4 equals 0. This gives us two factors. One of them is this puny little x, but that's a factor. The other one, 3x subtract 4, has a little more meat to it, but they're both factors. So we set each factor equal to 0. X equals 0, or 3x subtract 4 equals 0. Well, for this first factor, x equals 0, the x is already by itself, and so that's it. We're through. The other one, 3x subtract 4 equals 0, we must get the x by itself. So let's get rid of the 4 by adding 4 to both sides of the equation. 3x subtract 4 add 4 equals 0 add 4. And that gives us 3x on the left and 4 on the right. Then to get x by itself, of course, we divide both sides by 3. And that gives us on the left x, on the right 4/3. So we have x equals 4/3 as our other possible answer. Now, we've got two values to check. Let's check both of them. Remember that we checked them in the original equation. 3x squared equals 4x. So let's get our setup. The 3x squared equals 4x. We'll fill in the x value. Let's first check the 0. So we'll fill in 0 on both sides of the equation. On the left, we get 3 times 0 squared. Well, 0 squared is 0 times 0, which is 0. On the right, we get 4 times 0, which is 0. 3 times 0 on the left is 0, so we have 0 equals 0, which checks. For the other possible answer, we have 4/3. Let's fill in 4/3 in each expression of the equation. On the left, we have multiplying an exponent. The order of operations forces us to do the exponent first. Copy the 3, copy the parenthesis. 4 squared is 16, 3 squared is 9. We have 3 times 16 over 9. The 3 is, of course, 3 over 1. We're multiplying fractions. That means that it's okay to cancel before we multiply. This 3 and 9 just beg to be canceled. 3 into 3 is 1. 3 into 9 is 3. That gives us 1 times 16, which is 16, over 1 times 3, which is 3. So we get 16 over 3. On the right-hand side, we have 4 times 4/3. That's 4 over 1. 4 times 4 is 16. 1 times 3 is 3. We get 16/3 on each side, and so that one checks as well. So the two answers we get are x equals 0 or x equals 4/3. Here is example 3. We're to solve 2x squared is equal to x plus 15. This one is not in standard form since we do not have 0 on the right-hand side. We must eliminate the x and the 15 from the right-hand side. So let's subtract the x and subtract 15 from both sides of this equation. On the left we get 2x squared, subtract x, subtract 15. On the right we have x add 15, subtract x, subtract 15. And on the right-hand side we get 0. So standard form is 2x squared, subtract x, subtract 15. Now that we have standard form, we factor. To factor this one, it will be a guess and check. Well, to get 2x squared, we must have 2x times x. To get 15, we must have either 1 times 15, 15 times 1, 3 times 5, or 5 times 3. We know that to get negative 15, one or the other of these must be negative. The other one must be positive. So we're going to have a negative factor and a positive factor. Now, whatever we choose, we must multiply 2x times the last term in the second set of parentheses, and the second term in the first set of parentheses times x, so that our outer term and inner term, our outer product and inner product, will give us opposite of x in the middle. Well, the 15, 2 times 15, or 15 times 1 to go with the 2, that's not going to work for us. It's going to have to be the 3 or the 5, 3 and 5, or the 5 and 3. Well, if we do 2 times 5, that would be 10. 3 times 1 would be 3, 10, and 3 will not give us x. It's going to have to be, if anything works, the 5 and the 3 in that order. 2 times 3 to get 6, and 5 times 1 to get 5, and those we combine, if we're careful with the signs, to give us what we need. So let's put the 2x, put the 5 on the end to multiply times 2x, put the 3 on the inside to multiply times x. I've said it wrong, haven't I? Let's back that up and try again. 2 times 3 on the outer, and 5 on the inner. 2 times 3 to get 6, and 5 times 1 to get 5. Now, what signs do we need? We want 6x and 5x to combine to give us the opposite of x. That means the greater of those values must have the negative sign. So the 6x that we get from the outer must be negative. The 5x we get from the inner must be positive. So our factors are 2x plus 5 times x minus 3 equals 0. Now we can set each of those factors equal to 0. And solve. For the first one, we'll eliminate the 5 by subtracting 5 from both sides. 2x plus 5 subtract 5 equals 0, subtract 5. On the left we get 2x, on the right we get negative 5. Then we must divide both sides by 2, and that gives us x is equal to negative 5 halves. X is equal to negative 5 halves. For the other factor, we have x subtract 3 equals 0. We'll add 3 to both sides. X subtract 3, add 3 is equal to 0, add 3. And this gives x on the left and 3 on the right. So there's our other result. I'll leave the check to you. Our solution for this one is x is equal to negative 5 halves, or x is equal to 3. Let's do one more example together.